Air, wind, W-A-D-R-C-Y-L-D. Rain and cloud formation winds. The wind is named after the direction from which it blows. E.g., the wind blowing from the west is called westerly. Various factors that affect direction and velocity of the winds are pressure gradient, temperature differential, Coriolis forces, friction. Every wind system is a set of two subsystems: surface wind system and high altitude wind system. Surface wind system will develop if first its counterpart high altitude wind system develops, as it's shown in the cells. For example, in Headley cell, the surface system constitute easterly trade winds, while high altitude consists of what is termed as anti-trade winds. Note, anti-trade winds are those that blow in a generally westerly direction in the upper air above the easterly trade winds. Winds can be broadly divided into three types: permanent winds, seasonal, secondary winds, and local winds. Permanent winds or primary circulations. The trade winds, westerly and easterlies, are the permanent winds. These blow constantly throughout the year in a particular direction, and they are global in nature. These play an important role in, and in turn get influence to, formation of weather cell. 8. Headley cell. The air at the intertropical convergence zone hyperthesis rises because of convection caused by high insolation, and a low pressure is created. The winds from the tropics converge at this low pressure zone. The converged air rises along with the convective cell. As in the figure, Headley cell, it reaches the top of the troposphere up to an altitude of 14 kilometers and moves towards the poles. This causes accumulation of air at about 30 OM, and S part of the accumulated air sinks to the ground and forms the subtropical high denoted as STH in Fig. Another reason for sinking is the cooling of air when it reaches 30 OM and S latitudes. Down below near the land surface, the air flows towards the equator as the easterlies or trade winds. The easterlies from either side of the equator converge in the intertropical convergence zone hyperthesis. Such circulations from the surface upwards and vice versa are called cells. Such a cell in the tropics is called Headley cell. This is a hot cell, while polar cell is a colder cell. The feral cell. In the middle latitudes, the circulation is that of sinking cold air that comes from the poles and the rising warm air that blows from the subtropical high. At the surface, these winds are called westerlies, and the cell is known as the feral cell. C. Polar cell. At polar latitudes, the cold dense air subsides near the poles and blows towards middle latitudes as the polar easterlies. This cell is called the polar cell. These three cells set the pattern for the general circulation of the atmosphere. The transfer of heat energy from lower latitudes to higher latitudes maintains the general circulation. Seasonal winds or secondary/nasal scale. These winds change their direction in different seasons. For example, monsoons in India and cyclones. 8. Monsoon B. Tropical cyclones. Tropical cyclones are wind system with a low pressure at the center. It is a secondary type circulation, and it is embedded in the prevailing winds of the region. These are violent storms that originate over oceans in tropical areas and move over to the coastal areas, bringing about large-scale destruction caused by violent winds, very heavy rainfall, and storm surges. This is one of the most devastating natural calamities. Tropical cyclones in India both precede April to June as well as followed a monsoon September, November. However, the latter are more frequent. Energy of tropical cyclones comes from latent energy of condensation. They are known as cyclones in the Indian Ocean, hurricanes in the Atlantic, typhoons in the western Pacific and South China Sea, and willies in the western Australia. Tropical cyclones originate and intensify over warm tropical oceans. For a cyclone, there is a zone of convergence at bottom and there is a zone of divergence at top. Characteristics: isobars are circular and symmetrical. At the center, the pressure is low and pressure gradient is steep, and hence winds are very strong. However, I is calm and rainless. The winds form an upward moving spiral, so there are no marked wind shifts. Parts of a cyclone. High. It is a region of calm with subsiding air. High wall. Around the eye is the high wall, where there is a strong spiraling ascent of air to greater height, reaching the tropopause. Rain bands. From the eye wall, rain bands may radiate, and rains of cumulus and cumulonimbus clouds may drift into the outer region. Formation of tropical cyclone. The conditions favorable for the formation and intensification of tropical storms are large sea surface with temperature higher than 27 degrees Celsius, high relative humidity which is provided by sea and high temperature presence of the Coriolis force. They originate 8 to 10 degrees away from equator as they need strong Coriolis forces for their formation. Small variations in the vertical wind speed. They facilitate formation of cumulus cloud convection with condensation of rising air. A pre-existing weak low pressure area or low-level cyclonic circulation. Upper divergence above the sea level system. Easterlies and tropical cyclones in India. Around the month of October when monsoon is retreating over India, the easterly jet stream steers the tropical depressions into India. These depressions play a significant role in the distribution of monsoon rain all over the Indian subcontinent. A bulk of the rainfall of the Coromandel coast is derived from these depressions and cyclones. Such cyclonic storms are less frequent in the Arabian Sea. The tracks of these depressions are the areas of highest rainfall in India. The intensification of cyclone, the energy that intensifies the storm, comes from the condensation process in the towering cumulonimbus clouds surrounding the center of the storm. With continuous supply of moisture from the sea, the storm is further strengthened. Weakening of cyclone. On reaching the land, the moisture supply is cut off and the storm dissipates. The place where a tropical cyclone crosses the coast is called the landfall of the cyclone. The diameter of the storm over the Bay of Bengal, Arabian Sea and Indian Ocean is between 600–1,200 kilometers. The system moves slowly about 300–500 kilometers per day. The cyclone creates storm surges and they inundate the coastal lowlands. The storm peters out on the land. After the cyclone has passed, the clouds vanish and the air clears. This signals the approach of the following high-pressure area, or anticyclone, in which colder, drier air from the upper atmosphere circles down to Earth in a clockwise direction. C. Extratropical cyclones or temperate cyclones or weight cyclones. Extratropical cyclones, sometimes called mid-latitude cyclones or weight cyclones, are a group of cyclones defined as low-pressure weather systems that occur in the middle latitudes of the Earth outside the tropics, having neither tropical nor polar characteristics. Features. Extratropical cyclones are the everyday phenomena which, along with anticyclones, drive the weather over much of the Earth, producing anything from cloudiness and mild showers to heavy gales and thunderstorms. Extratropical cyclones form along the polar front. Initially, the front is stationary. In the northern hemisphere, warm air blows from the south and cold air from the north of the front. When the pressure drops along the front, the warm air moves northwards and the cold air moves towards south, setting in motion an anti-clockwise cyclonic circulation. The cold front moves faster than the warm front, ultimately overtaking the warm front. The warm air is completely lifted up and the front is occluded and the cyclone dissipates. The processes of wind circulation both at the surface and aloft are closely interlinked. Extra/temperate tropical versus tropical cyclones. The extratropical cyclones have a clear frontal system which is not present in the tropical cyclones. Tropical cyclones are thermal in origin and hence possess more energy which they owe to warm oceanic waters, whereas extratropical cyclones are frontal in origin. This is the reason that tropical cyclones start dissipating as they approach land, as their source of energy is cut off. Extratropical cyclones cover a larger area and can originate over both the land and sea, whereas the tropical cyclones originate only over the seas and on reaching the land they dissipate. The wind velocity in the tropical cyclone is much higher and it is more destructive. Tropical cyclones are less frequent, but more destructive. On the other hand, extratropical cyclones are less destructive but more frequent. The extratropical cyclones move from west to east, but tropical cyclones move from east to west. For tropical cyclones, the circulation of air in the northern hemisphere is anti-clockwise.